3.1 goes over functions. Functions are just relationships where you have one output for each input. So each input has exactly one output, and that is a function. If we look at these examples, we're determining whether each relation is a function. In order for something to be a function, your x values cannot repeat. So your x values will never repeat if it is a function. If we look at example A, we have negative 2, 2, negative 1, 2, 0, 2, 1, 0, and 2, 0. Our x values here do not repeat themselves, so this one is a function. For B, we have 4, 0, 8, 7, 6, 4, 4, 3, and 5, 2. Now, the 4s repeat themselves, so this is not a function. For C, we have our input, which is negative 2, negative 1, 0, 0, 1, and 2. Those are our x values. In order for this to be a function, our x values cannot repeat. We do have 2 zeros here. So because we have 2 zeros, this one is not a function. For D, our input is on the left side and our output is on the right side. Our input, we only have one arrow going from each one of those x values, so this is a function. For E, we have negative 5, 0, 5, negative 5, 0, 0, 0, 5, 0, and 5, 10. Those x values of the 5s repeat, so this one is not a function. For F, we have negative 4, 8, negative 2, 1, negative 1, 2, 2, negative 4, and 5, negative 10. None of our x values repeat there, so this is a function. For G, our input is 2, 4, 6. Our output is just 2.6, 5.2, and 7.8. None of those inputs repeat themselves, so this is not a function as well. And then for H, we have multiple arrows going from that input of that 1/2. So because our x repeats 3 different times here, this one is not a function. When I look at this over again, G is a function because your x values do not repeat. So I'm sorry, but this is a function. There we go. If we look at our next part, we're determining whether the function is a graph by if the graph is a function, looking at the ordered pairs or the lines that are on these graphs. Just like we just looked over, our x values can't repeat. So if we draw the vertical line through these points at any point in time, there should never be more than one point that intersects that vertical line that we draw through. So we can draw a vertical line through any part of the graph to see whether or not it's a function. For example, A, if we draw, let's say, a vertical line here, we have 2 ordered pairs that go through that vertical line, so this is not a function. For example, B, let's say we draw our vertical line here. We have one intersection here, so this is a function. For example, C, we draw that vertical line through these points. It doesn't matter where this vertical line is. If we were to take it and move it anywhere, it would never intersect more than one time with any of these points. So this one is a function. For example, D, again, we can just draw that vertical line anywhere on that graph. It only intersects once, so this is a function as well. For E, we have this circle on this graph. So again, we can draw a vertical line through that circle. It intersects twice, so this one is not a function. For F, again, draw that vertical line. It only intersects once, so then this one is a function as well. For our next part, we're just finding the domain and range of the function represented by each graph. Your domain are your inputs, those are your x values, and your range is your y values or your outputs. So if we look at example A, we have the ordered pairs here that are -3, -2, 0, 1, -1, 0. Then we have 1, 2, and 3, 4. So our domain are our x values from these ordered pairs. So it's -3, -1, 1, and 3. Our range are the y values from those ordered pairs. So it's -2, 0, 2, and 4. For example, B, this one's a little different. This one doesn't have specifically just ordered pairs. There's a line between these two ordered pairs. So that line covers those x values from the -2 to the +3, as well as the y values from -1 to +2. So we want to look at our domain as anything from the smallest to the largest x value. So we're dealing with x. We're going to write a compound inequality from this. So x is greater than or equal, because it's a closed circle and it includes that, -2. And then x is also less than or equal to that +3. For your range, that's your y values. So the smallest that you have there is the -1. The largest that you have there is the 2. So we're going to put the -1 first. We're dealing with y since it's range. And then our last value is going to be that +2. Our y values are greater than or equal to -1. And then they are less than or equal to the 2. So all of our x values that are covered are anything from -2 to 3, including -2 and 3. And our range values or our y values are anything from -1 all the way to +2, including the -1 and the 2. For example, C, we have these ordered pairs that are -2, 4, -1, 2, 0, 0, 1, 2, and 2, 4. Our domain values are those that are the x values. So that's going to be -2, -1, 0, 1, and 2. And our range are the y values. So that's just 0, 2, and 4. And you realize when I drew these domain and range values like this, I have my numbers in order from least to greatest within those brackets. For example, D, we have this U shape that we see, and our values for our domain, which are our X values, is going to be from 1, we're dealing with X, all the way to 5. We are including the 5 and the 1 since there's closed circles here. So with this, the X is less than or equal to 1, and X is greater than or equal to 1, and then X is less than or equal to 5. For our range, we have our Y values. We're going to all the way up to 4, and we are dealing with 0. So the 0 will come first, the 4 will come last. Y is greater than or equal to 0, as well as less than or equal to 4. So for our domain, we have all the values that are between 1 and 5, including 1 and 5 for our X's. And then for our Y's, for our range, we have anything between 0 and 4, including 0 and 4. Okay. So with our next set of examples, we're identifying independent and dependent variables. Your dependent variable will always be your Y, it's your output. Your independent is always going to be your X, or your input. You got to think about these like what depends on what. Whatever you're getting out of the equation depends on what you put into the equation. So your inputs are always going to be your independence. Then your dependence will always be the output because it's what you get from putting something else in. If we look at example 4a, it tells us that the function y is equal to negative 3x plus 12 represents the amount y of juice remaining in a bottle after you take x gulps. A says to identify the independent and the dependent variables. So what you put in there is your x, that's your gulps, that's your independent. So the independent is the gulps, and then your dependent is the amount left over. It tells you for B the domain is 0, 1, 2, 3, and 4. What is the range? So with this, you can write out or draw a function table in order to solve what your range is. We have x values, a domain of 0, 1, 2, 3, and 4. If we solve this, y is equal to negative 3x plus 12, we are going to get those y values. So if we plug these values in, we have negative 3 times 0, which is 0, plus 12. That gives us a y value of 12. Then we have negative 3 times 1, which is negative 3, plus 12 is 9. For 2, we have negative 3 times 2, plus 12. Negative 3 times 2 is negative 6, plus 12 is positive 6. And then we have negative 3 times 3, which is negative 9, plus 12 is positive 3. And then we have negative 3 times 4, which is negative 12, plus 12, which is 0. So when our domain is 0, 1, 2, 3, and 4, our range is 0, 3, 6, 9, and 12. For our next example, we have a is equal to negative 4b plus 14 represents the number A of avocados you have left after making B batches of guacamole. A says to identify the independent and dependent variables. So A says independent are the numbers of avocados. Your dependent is the batches of guacamole. For B, it tells us the domain is 0, 1, 2, and 3. We're finding the range. So that's our X, or our, in this case, our A. Our independent is so hold on. It tells us the function A is equal to negative 4B plus 14 represents the number of A avocados you have left after making B batches. So these are actually switched. So this is your dependent, and your independent is the number of batches. So the domain is 0, 1, 2, and 3. So we're plugging these in for B into A is equal to negative 4B plus 14. And we're solving to get A. So we plug in that 0. Negative 4 times 0 is 0 plus 14 gives us 14. Negative 4 times 1 is negative 4 plus 14 is positive 10. Negative 4 times 2 is 8. Negative 8 plus 14 gives us 6. Negative 4 times 3 is negative 12 plus 14 gives us 2 left over. So our domain is the 0, 1, 2, 3. Our range is 2, 6, 10, and 14. For our last example, it tells us the function t is equal to 19m plus 65 represents the temperature T of an oven after preheating for m minutes. A says to identify the independent and dependent variables. So our independent is the minutes. And your dependent is the temperature. For B, we're identifying, or tells us that a recipe calls for an oven temperature of 350 degrees. Describe the domain and range of the function. So your temperature can go from anything between, or your minutes can go from anything between 0 to whatever the temperature needs to be to get to the 350. So what we need to do for this is we need to plug in the 350 for the temperature is equal to 19m plus 65. And we're going to subtract the 65 from each side. We get 285 is equal to 19m. From here, we just divide each side by the 19. And m is 15 minutes. So our domain is anything from 0 to infinity, or 0 to 15. And then the temperature is going to go from your 0 to 350. So in order to write this, we can say that the domain is 0 is less than or equal to x, which is less than or equal to 15. And our range, we have 0 is less than or equal to y, which is less than or equal to 350 degrees.